All right, go ahead.
All right, welcome everybody. Welcome to the second meeting of May. This is the official one. So here's the agenda for today. We're gonna start with the usual news from mainly Gazebo news from Adisu, and then the main talk today is about GzWeb. So we will have Nate and Herman from Intrinsic and Ecomen to talk about visualization of Gazebo in the browser, and then we'll have probably some time for questions. So Adisu, all yours.
All right, thanks, Carlos. Welcome, everybody. Just a little bit of news from Gazebo. The first one is that I've mentioned this before, but we are migrating from answers.gazebosim.org to Robotic Stack Exchange. So please go ahead and click on that link. If you are active on that on Answers, there's a form you need to fill out to make sure that your name is mapped correctly when we migrate. And if you have, there are some other action items there, maybe to upvote some of the good answers that you found, or if a question has no votes, I don't think it'll be migrated. So so please read that and kind of follow the directions there. The second one is Ross Iron Irwiny has been released. So that was a big release I'm sure you've heard of. It is going to be paired with Fortress. We're currently working on getting binaries for Garden from our packages.osrfoundation.org repo. But you need to know that officially it's Fortress is supported. Until we get these binaries rolling, you need to compile from source to get Iron support with Gazebo. Next up is so our harmonic release is coming up. It will be released in early October. We've decided that we're not going to be supporting Focal because that will be too much of a burden for us to support Focal, Jammy, and the next version, which is 2404. So we're going to be only supporting Jammy and 2404. And last but not least, we have the new releases. If you click on that, there's a lot of releases. It's been a while since we made posts for releases, so go check it out. There's been quite a few changes that I think improve Gazebo. So check it out. That's all from me.
Thank you, Adisu. I'll mention also that right now it's ICRA. It's happening in London, and Monday there was a workshop organized by Chris and Mabel, so that there's been some tutorials and some extra documentation that probably will organize and announce here, just in case it's useful for anybody. So we'll have some extra materials around. All right, so then the next is the talk from Nate and Herman. So they're gonna talk about GzWeb. So I remember at least, I think 10 years ago, probably, like when we were working on the Data Challenge, there was this thing called CloudSim, and for running simulations in the cloud, and I believe around that we started the first version of GzWeb. So it's been almost 10 years and many iterations, so it's great that it's still around, and probably Nate and Herman are gonna describe the news in the latest development. So Nate, Herman, you're up.
All right, thanks, Carlos. And there's a slide in here that is about the history, and I am going to look to you, since you seem to have some more information. Where I ideas about what I think the history was, but I'm pretty sure I'm not 100% correct. So this is also an opportunity to make this a little bit more interactive. If I say anything that is just blatantly wrong, feel free to just chime in and correct the record. I've really only been doing GzWeb work in the past 4 years with Herman and a few others. So my knowledge is mostly within that time frame. So, right, so Herman's on this call. Herman, you want to wave your hand so people know where you are on the screen? Come on, wave your hand. There you go. He's down in Argentina. He's been working with us for quite a while on various aspects of cloud infrastructure and Gazebo, and in this case, GzWeb. We call this GzWeb version 2. This is not a name change. We're not doing anything crazy like that, but we did want to recognize that this is a pretty big change from the original GzWeb, which worked with Gazebo Classic. It's still trying to do the same thing, which is basically visualizing Gazebo instances, Gazebo state via a web browser. So I'm going to start on a silly tangent. Since I am, everyone thinks they're old, but I think I'm relatively old. Why not? The internet really has gone downhill since the 2000s. I can't think of, honestly, anything good that has happened since then. If you're not familiar with Jumping the Shark, which I haven't heard in quite a while, but you should go check it out. It's a fun little, it was a website from the 90s, I believe, and it was actually bought in the early 2000s for a couple $1 million, which is crazy. Anyways, that's just to set the stage of local command line tools and graphical interfaces are, frankly, awesome. I use them all the time. It's a really easy way to do rapid development and test. You don't need the internet, importantly. So if you're ever on a plane, you can put your wallet away and not pay that $20 for really bad internet service and keep working, which is great. It's relatively simple to use these tools. Ideally, they're simple. We've tried our best to make them simple and extensible. You can write these in your own scripts, do a lot of powerful things, all on your local PC. And you get the advantage of local compute. This is not to say that your browser is not also taking advantage of physical attributes of your PC, but a lot of libraries are optimized and designed to take advantage of your GPU, and they can operate without having to be within a browser. As a point of context, most games or most modern games are not running in the browser, right? They've been optimized heavily to run natively in order to take advantage of all the bells and whistles that come in your, $10,000 graphics card. I've heard that's what people are paying these days. I'm going to choose to buy a graphics card and not send my kid to school. That's my own decision. Don't judge me. But there are clouds. There's a lot of compute available out there, which is very attractive to a lot of people, including myself. It offers a very scalable resource for running Gazebo or running, frankly, any application that you want. It's relatively low maintenance. You're right, just ChatGPT. I agree with you, Marco. Yeah. So it's low maintenance. I'm not going to say it's zero maintenance. Anytime you start using a compute instance, there's always going to be some maintenance. Someone has to monitor and make sure it's up and running. But I would argue it's lower maintenance than say like running your own rack or running your own PC. In fact, I spent a lot of this morning just making this laptop work again. So headaches. Anyways, some of the nice things that you can do in the cloud are run competitions. We've been doing that at Open Robotics for over a decade, and other people have been doing it as well. It's a great place to run simulation in a controlled environment. ML is a hot topic, using simulation, whether it's Gazebo or Lojoko or other tools, to get training data out is a great use case for cloud compute. Of course, testing, a lot of CI or CD systems are using cloud resources. And you may have heard of this thing coming out of Intrinsic called flow state, which is using simulation under the hood. So web services can utilize Gazebo on cloud compute to offer environments in which people can design systems and test them before deploying them to robotic applications. So that's all well and good. But running in the cloud doesn't mean you can actually easily see what's going on unless you have some way to visualize simulation state. So ideally, any person can open up their browser of choice. I'm not going to play favorites here. I personally go for Internet Explorer all the time. As you can see, this is definitely not Internet Explorer. What am I doing? Anyways, this is a cross-platform, assuming your browser is cross-platform, which I think most of them are. It's a relatively low barrier to entry, so as long as you know how to operate a keyboard and mouse and can type in a URL, you are usually good to go in terms of at least visualizing simulation. There's caveats here, of course. Someone has to have set up cloud compute for you if that's not you yourself. So that low barrier to entry is kind of ignoring the fact that someone actually has probably Dockerized Gazebo in some form, deployed it, and has it running and maintained on a cloud resource. There's also other caveats, such as just the nuts and bolts of debugging what's going on. It's harder if you're operating through a browser. It's much easier if you're running, or at least have a terminal open to simulation or your ROS system, so that you can use your favorite command line tools and so forth. So there's trade-offs here, but there's definitely benefits if you can run Gazebo in the cloud and see what's going on in the browser. So that's exactly what we're talking about today. We're ideally addressing that point of running Gazebo somewhere. Technically, it could be on your own, on the same system that you're using GzWeb, but it doesn't have to be. So I've talked about most of these points. The main differences here is that Gazebo is using native tools, native libraries. For better or for worse, you may have opinions about Qt and Ogre. This is Linux. It doesn't necessarily have to be Linux. We do support Mac. Windows, I will squint, and if you ask me any questions about Windows, I may walk out the door, but that's neither here nor there. It's relatively easier to just get up and running with Gazebo natively. If you're doing the standard apt-get install, you can get a Gazebo environment, running on your system in a matter of minutes. If you wanted to use any cloud infrastructure, you obviously have to jump through whatever hoops are in place, whether it's AWS, Google, or Azure, choose your poison. Importantly here, 3JS does not necessarily equal Ogre, so the output you get from 3JS, it will be close, and we're trying to make it closer to what you see in Gazebo, but it's almost guaranteed to never be exactly the same. For most use cases, and my lights are going off. Technical difficulties. I'll leave that be. For most cases, that's okay. It depends on exactly what you're trying to use GzWeb for. But if you're just worried about seeing simulation states, you can rely on Gazebo under the hood to generate sensor data for you and have that fed into your control system in this normal fashion, and you can see what's going on in the simulation. Okay, now this is crazy. I have to move around. Great technology. And of course, there's overhead with just getting data from Gazebo into your browser. So WebSockets are non-trivial overhead here, in particular since there's caveats where you don't really want to open up a whole lot of WebSockets to pipe data in from Gazebo to your browser. And I'll talk more about this in terms of trying to take data from Gazebo and multiplexing it over WebSocket connection onto GzWeb, which is a common approach. Foxglove does a similar strategy when they're getting ROS data through a WebSocket connection. So this is where I think I'm mostly kind of sort of accurate about how things came around. I believe, based on my introspection of Git and GitHub and other places where code has lived, GzWeb started roughly around 2013, and I think I saw Louise join in. She might have pushed back on that. The original Gazebo Classic approach was to run a Node.js server acting as a bridge that would connect to topics and convert messages to JSON and pipe that over a WebSocket connection to GZ3D. There was, and still is, for the original version of Gazebo, 2 different things. One called GZ3D, which is for visualization, and GzWeb, which had a set of tools, graphical tools, to support insertion of models, move things around, and so forth. So over the years, this project was maintained and pushed forward, used in various projects. I believe it was used in Mentor 2, which I had completely forgotten about until I was making this presentation. This was a project run by DARPA, I believe, to help educate people about robots in general. So I think we were building things like toy cars that used ROS and had some simulation aspect in there as well. And more recently in the Space Robotics Challenge, and the one I'm most familiar with was the DARPA Sub-T Challenge from 2017 to 2021. This is the time period in which Gazebo had a major upgrade to a name which shall not be spoken. It also gave us the opportunity to upgrade GzWeb. So since Gazebo is changing and we're changing a lot of code, why not change all the code? Because more is better, right? So that gave us an opportunity to look at some requirements here. I was pretty keen on getting rid of Node.js as a separate server and using a C++ WebSocket server with the goal of eventually getting this more tightly integrated with Gazebo itself, so we don't have to run multiple services or multiple executables in order to get GzWeb working. We can also utilize some JavaScript libraries that can consume protobuf messages, so there's not a need to deserialize and convert protobuf messages on the server to JSON. So we get to keep all the nice benefits of understanding the types within messages and preserve data integrity as Gazebo produces it and sends it over the wire through WebSocket services, WebSocket connections, sorry. We also reduced the scope. It was going to be a little bit easier for us to package and ship just the 3D visualization portion of GzWeb. So this was, the GZ3D portion of the original GzWeb, just to confuse you with names. GUI tools are, the code is still there, we're just not packaging it up into an NPM package. Right now, you just get the visualization aspect of GzWeb. The graphical tools are a TBD at this point in terms of who implements them and where they get released. We also wanted to look at reducing the gap between Ogre 3D and GzWeb. So we added physically based rendering or PBR support to GzWeb. I didn't list here, but now think of it, we had particle support. So I think in one of the demos you might see snowflakes. Ooh, snowflakes. And that also supported fog and things of that nature within GzWeb. And some other minor details like improving our cloud handling and and so forth. It's still not going to be an exact one-to-one visualization between Ogre 3D and GzWeb, but it's getting closer. And we improved our integration with Fuel. Most notably, GzWeb will pull assets from Fuel when they have been specified in your world. And if you happen to have, if one of those assets or models is private, GzWeb will access that, assuming that you have a valid JWT token. So this can be useful if you're running a competition, for example, which has a private world that you don't want competitors to see, but you still want to, say, have competition administrators visualize that world during a competition run. All right, what does this look like in broad strokes at the architectural level? So let's assume that you have a Gz server running that is publishing data via Gz transport over topics, and protobuf messages are being used as the message encoding. If you also have GzWeb on the other end, that will connect to a WebSocket server currently run by Gz Launch. So you have to run both Gz server and Gz Launch in order to get your WebSocket connection set up. GzWeb will ask the WebSocket server to subscribe to a certain set of topics, which Gz Launch or the WebSocket server will happily do, and start sending those messages over a WebSocket connection to your browser. GzWeb on its side will consume those messages, deserialize them, and use them to populate a scene, which is backed by 3JS, and protobuf.js is used to do all the message handling on the JavaScript side. And of course, any interactions with Fuel is also handled from GzWeb. So just for your own benefit, in case you're curious about what I mean by multiplexing topics, so your WebSocket server will or can connect to multiple named topics from Gazebo and package those into a single connection where it's an operation, topic type, and message type and payload as one packet of information that goes over the WebSocket connection. So as an example, if topic A was publishing a string that said hello, you'd get that quoted example below, with the caveat that hello would actually be the serialized string, not just plain text. Okay, so I think I've talked about most of these features. The ones I'll touch upon are there's no deserialization on the server, so it's just a straight copy, so there's no overhead associated with that on the server side. You can add SSL certificates if you want to on the WebSocket server, and you can also control the number of connections if you need to limit simultaneous access to your WebSocket server. If you want to make things pseudo-private, I say pseudo because these are just plain text authorization keys. You can configure the WebSocket server to only accept connections that have passed over a matching key. I wouldn't try to pass this by a security expert and say this is guaranteed to be safe, but it's better than nothing. I already mentioned private Fuel assets, and one nice thing under the hood is GzWeb doesn't currently require all of the messages to be defined within the JavaScript library. It fetches the message definitions from your running Gz server instance at runtime. There's pros and cons to this. The pro is that GzWeb can work with different versions of Gazebo. The con is that on GzWeb side, it has to be careful about how it interprets those messages because it's relatively easy to get a message, deserialize it, and if you don't check types properly, you could start assuming that protobuf message has contained data that actually didn't. And of course, if a version of Gazebo comes along that has significantly changed messages or message formats that GzWeb isn't able to handle, it won't render anything. But it does allow us to have a single version of GzWeb that can work with, I believe it works with Citadel, Fortress, and Garden. All right, roadmap. And the caveat here is that this is probably slower going than the main Gazebo roadmap. We are working this as time permits and people are express interest. So there are some improvements from sub-T that we want to finish porting over, namely visualization of laser scans and camera images. We have those supported in a bespoke manner on sub-T. Some of the infrastructure is there on the WebSocket server side, but not on the GzWeb side. There is some parity differences between what Gazebo can do natively and what GzWeb can do. Basically, if you add anything to GZ rendering, it's not going to be reflected on GzWeb unless you go through the effort to make that happen. So lens flares, projectors have been recently added, are not supported on GzWeb, as well as some simple shapes that were added maybe a year ago by now, but those also won't render on GzWeb. As mentioned before, I want to get the WebSocket server out of launch and into a more convenient and easily consumable place, whether that's transport or SIM, it's to be determined. And of course, more data visualization, because I like data and it's going to be useful if we can do some simple things like visualizing moment of inertia, joints, and so forth in a similar way that you can do on the native application. Of course, contributions are welcome. I know this is something we always say, but we have had some nice developers in the past develop cool features, add and contribute to GzWeb. This is a combination of the original GzWeb and the more recent version of GzWeb as well. So thanks to all these people. Back in the day, Brian even contributed. This was during the DRC days. I found a commit from him. He actually wrote JavaScript. You can ask him about it sometime. It's relatively easy to get this going. There is a version of GzWeb built into the Gazebo Sim website. So if there's a big, I wonder what happens if I click this. Of course, it's not sharing the screen. Let me show this down. There's a visualization tab over here, and you can connect to. By default, it just populates in your local host. So if you happen to be running GZ server and the WebSocket server locally on your computer, you can connect and visualize it here. If you happen to have a publicly accessible IP and port of a remote instance of the WebSocket server, you can also connect to that and visualize it in this web application. Jump back to the slide. And generally, you just have to run two things. Run some world and run the WebSocket server and then connect. And this is my transition point in which I am going to hand over the speaking stick to Herman to run through some demos. Are you ready, Herman?
Thank you. Yeah, let me share my screen. I will show you guys how to use GzWeb in an application from scratch, so you can. Let me see. So you can take a look how easy it is to use GzWeb nowadays, the latest version. So you should be seeing my screen here. So we have this application that basically has two routes, one for viewing a static asset, a model or world, and the other one to connect to a running simulation, just like Nate showed you. The repository is quite easy. This is an Angular application from scratch, and we only need to run npm install GzWeb, and you will have it available. So I will show you how can you run, you see an asset, for example. If you click here, this model will get loaded, and you can see it, move it around. This is not using any kind of live simulation. This is just rendering the model itself. If we go to the code, you can see the asset viewer here. It is quite easy. We have only one div which acts as the container for this, and we need to create, instantiate the asset viewer with a certain kind of configuration and render the files here. The only thing that you need is an array of all the URLs of the resources you use for that model. So we have here the model SPF, that inside it has all the model link, visuals, and everything you need to see that model. Behind, under the hood, this is in charge of parsing that model SPF file and map the SPF structure into a tree structure for 3JS, right? So the model itself will end up being an Object3D that has as children all the links and everything related to it. Once that Object3D is ready, all the meshes are loaded and the textures are loaded, that gets added to the 3JS scene, and we can see it here. This is what you see when you go, for example, to app.gazeboscene.org, and you can visualize each model or world without the need of a live simulation. So let me run a live simulation now, and I will show you how the visualization part they told you about works under the hood. This is all under the scene manager, and you can see all the code here. And as you can see, it doesn't require much. It requires a WebSocket URL and key. What container do we need? And that's it. Once we create the scene manager with this, behind the scenes, GzWeb will try to connect to this simulation, get the proto definitions, connect to all the necessary topics, such as the scene information and the dynamic pose. And as you can see, it will do so for you without any interaction here. Let me run a simulation here. As you can see, I have here GZScene Worldscape. Let me run that, and you can see Gazebo here once it loads. You will see the world here with a couple of things that I added to show you some functionality. Well, in the meantime, we can, on another tab, run the WebSocket server. Here is the stock WebSocket server that comes inside the GzLaunch repo in examples. So we can run this, and that opens the WebSocket in this particular port. Here we have the world. As you can see, there are some floating spheres there. And this particular simulation is not yet running, so everything is static so far. Now let me connect to it. It's this particular URL. We don't have a key yet. I can show you how to add one. And then we click connect. And then behind the scenes, as you can see, we get all the proto definitions. We get the scene information, which asks the WebSocket server, okay, what models do you use here for us to render everything in the browser? And we also have subscribed to the dynamic poses of all the models here. So we know, for example, the pose of each of these models. And once we get changes in them, we will see them reflected here. I don't know if you can see, but I added a particular particle emitter here, a bunch of snow. That's one of the differences you will see with Gazebo. So what happens if I click play? Since GzWeb already subscribed to the dynamic pose of these models, once we have changes, they will see reflected here without us having to code that. GzWeb does that for us. So if I click play, you can see the spheres will fall down, and that gets instantly reflected here. We know all the pose changes of all the models, and we reflect them in the scene. As you can see, the particles look slightly different. It is because we don't have the same rendering engine. And that's it. You can see all the, if you have a robot running around, for example, you can see it reflected here in the browser. I am running the simulation locally, but the simulation can be run in the cloud, and we can connect to it using the right URL.
And there are some helper functions in GzWeb to do things like move to objects, follow objects, and things of that nature, which you can choose to use or not. And I forgot to mention one thing about how assets like models are served. So I talked about getting, the GzWeb will get models from fuel if it's been specified. It will also now fetch models from your Gazebo simulation instance as well, if it can't get them or doesn't, or if URL or model path is such that it can't get from fuel. So Gazebo will serve the assets, meshes and materials, and send that over the wire as needed to GzWeb.
That's a good point. Thank you for the mention. If one asset is not, you cannot obtain it, the simulation will stream it through WebSocket, and we use that one. So that was a big improvement, and allows you to have maybe private models that you don't want to upload. You can stream them directly this way. And for the functionalities, I have a couple of buttons here that calls particular methods of the scene manager or the Script.js scene directly, so you can see how can we interact with a scene this way. If you go to the code, these are only method calls, very simple. We have a lot of functionality regarding models. We can select models, move to them, follow them with a particular camera setting, either first person, third person. We can, for example, if the view goes wrong, we can reset it and go back to the beginning. We can take a snapshot. That's all that happens on the scene manager itself. We have here the image. This is good for if you want to take thumbnails, for example. This is a good functionality. And we also can, for example, subscribe to another set of topics. All this scene is subscribed to the scene info and the dynamic pose topics, but you can subscribe to any topic that you want and react to those messages accordingly. For example, we had another project that required all this information to show, and these are particular topics. For example, the battery, the angle, the velocity, and we can subscribe to those and show those values here. So it's and it is also a two-way communication. You can subscribe to messages, but you can also publish into a particular topic that you set. So you can send information to the simulation from the browser itself.
I believe you can also make service calls now. Is that true? That's how we did audio, right?
I think yes, we have audio and service calls, if I remember correctly. And yes, for example, the good thing about having Three.js behind the scenes, Three.js is a very, very good 3D render for the browser, and it has a lot of funny things that you can do. For example, you can add fog into the scene. This is totally unrelated to the gazebo itself, but since we can take advantage of the 3ds scene, we can use these kind of methods, for example. So anything that you can do on Three.js directly, you could do on GzWeb as well. And I don't think I have
I can take that one.
Okay.
So there's, I mean, it depends a lot on your internet connection. Ideally, we're not sending a lot of data over the wire. So there's, to give you an idea of what happens when GzWeb initially connects to the scene or GZ server, there's an initial handshake that gets the scene information, and then GzWeb will download assets from Fuel. From that point on, it's really just subscribing to pose updates, which is not a lot of information depending on what you are simulating. So if you have, I don't know, thousands of spheres all falling down, that might be an error case, or I should say error case, that might be a pain point for GzWeb. But during the sub-key competition, when we used this, we had up to a dozen robots moving around, all setting their state with other dynamic objects in the environment, and it operated just fine. So if you're within that bounds, it works fine. We haven't, measured where the boundary is. What is the point at which it becomes unusable or lags behind?
Yes, I do remember having, for example, having to limit the subscription to images, for example, because those were particular big messages, and we couldn't subscribe to too many cameras, for example. But for just visualizing a scene with robots going around, we never had any performance issue on the WebSocket side of things.
Yeah, we did do a test for the maximum number of connections to the WebSocket server before we started seeing problems, and it was on the order of a couple hundred, if not more, if I remember correctly, where there was no dropping of messages or loss of communication if you had a few hundred simultaneous connections to the WebSocket server.
As for the real-time factor, the browser uses whatever the simulation publishes. So I believe that if you have a low real-time factor, that will be reflected. The only thing that I believe doesn't follow that is regarding the particles. Showing the real-time factor. If that information is available on a topic, you can have it. You can subscribe to that particular topic, and you will get that response.
Yeah, we showed that during sub-key. People were interested in seeing their real-time factor, elapsed time, and that kind of thing. So that was just subscribing to the right topic and just displaying it. You can either do it as an overlay or as a text box in your web application. We do, yeah. So on that point, the mechanism to subscribe to topics is exposed in GzWeb, so it's relatively easy to create your own subscriber or publisher in a way that is similar to what you would do natively, but with the caveat that you're writing JavaScript. So essentially, you give it the name of the topic and a callback, and then every time you get a message for a subscription, that callback will be hit with a with a message payload. I think, Herman, you're pausing here because this is time for questions.
Yes.
But if there are more, happy to answer questions.
Yes, I don't think I have anything else. So if anyone has any question, I'm free to answer.
Thank you so much, Herman and Nate. Questions? I have one in the meantime. So considering how quick everything changes in the web development ecosystem, how good was the decision of choosing Three.js, or how stable it is?
I think we've been using Gzweb from the beginning, and so far it's been working out well. I know that there's under the hood that there's a movement towards a new. So Three.js is a wrapper on top of I'm not gonna remember the name, but the actual WebGL. Thank you. And there's a newer WebGL, which they're calling WebGPU or something of that nature. Yeah, WebGPU, thank you. So Three.js is moving towards WebGPU, so we should be able to stick with Three.js and get the benefits of WebGPU. We honestly never went down the road, as far as I'm aware, of trying to use WebGL or WebGPU directly. I think taking advantage of a large community around Three.js is advantageous to us. In a similar way, we're not directly implementing OpenGL on the native side. Take advantage of Ogre or other 3D engines.
I agree. In retrospective, choosing Three.js, it was a very good call. It has a very large community nowadays, and whenever there is something in the 3D rendering world, such as WebGPU, it starts developing as soon as it's out of the gate. So the WebGPU has been talked about in the Three.js community, and it will be most likely be implemented sooner rather than later. And yeah, it's a very big community, like I said, and all the problems that you face, someone already did. So it's very easy to work with.
Thank you. And when I think Nate mentioned that it is possible to have multiple connections between the browser and the Gazebo server. Do you mean, like, is it possible to have multiple browsers connecting to the same Gazebo server?
Yeah, exactly. So if in this case, what you're looking at, if Herman had his computer publicly accessible, Herman could connect to his server, I could connect to it, you could connect to it. So it's, assuming authorization keys are not set or you have the right authorization key, that type of thing. That's
Exactly. For Subti, for example, we had all the simulations running in the cloud, and users got their URL from an endpoint. So all teams were able to see their own simulations, for example. They logged in, they got that direction and their keys, and they could connect to it. And everyone in the team were watching the same simulation running in the cloud. We can also limit the number of connections if we need in the WebSocket server. By default, it's unlimited, but if there is a need to restrict the number of connections, we can do so.
Thank you. More questions? All right. Maybe one round of applause. speakers today.
Good job, Ron.
Okay, so
It's in Babylon?
Yes.
What is Babylon?
Babylon is another alternative to 3JS. It's one of the big renders available, and it is now on Babylon.
More options, always a good thing.
just a question about if we have compared that with 3JS.
I didn't compare them myself, but I know there are some. I heard there are some good cases to use Babylon and good cases to use 3JS. I don't think we have ever met any kind of blocker using 3JS. The only thing that I would say it's not we had to take a look around was particles, because 3JS doesn't have a particle engine native to 3JS, so we depend on third-party libraries for that. That's the only thing that the only problem I would say we face with 3JS, but it wasn't a very hard blocker for us.
All right, thanks again. And going back to the agenda, is there any, we have like 4 minutes, so is there any other question in general related with Gazebo, not with the talk necessarily?
There's 2 months until feature freeze. Did you already mention that? 2 months, get your features into Gazebo for Harmonic. Sorry, yeah, Harmonic, yeah.
All right, so there are no more questions. I think we can turn it down here. So thanks everybody. See you next month. Ciao.
Yeah.
Thank you.